Hello, PreCalc. This video is to be viewed sometime after Thursday's class. So I guess that's the 4th. So the 4th, 5th, 6th, 7th. And we meet again on Monday. I guess that's the 8th. So sometime in that time frame, please watch, take notes, and let's go ahead and see what's in store. We've been studying the difference quotient, piecewise functions, and now we're looking at parent functions a little more. And we're actually going to do a parent function project. So the parent function project will actually take place in your comp book. So for a period of time, I'm going to have to collect a couple comp books at a time until I get them graded. The reason I'm doing it in your comp book is so that you will have it. The comp book is supposed to be a guide for your future math classes. You can just keep it with you, and hopefully there's a section with formulas in it. If it isn't, we'll make one when we're studying for the final. We'll just collect everything in one place, which will be useful in future math classes, whether they're on high school level or college level or wherever. And then you have examples of everything from pre-calc class. So you're going to need, here's what is required for the parent function project. You will come up to draw all 8 functions with their names, and you will find various aspects about each one. So I'm going to take one and do the whole thing for you, so then there'll be only 7 left for you. So I'm going to do the absolute value function. So first name it with words, then name it with mathematical symbols, and then sketch it. So now I'm going to ask you to find several aspects. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about 11 different things. And the first thing you will do is to conduct the vertical line test. So the vertical line test determines whether or not we have a function. So I'm going to put in several vertical lines, and our minds, our beautiful minds, are going to put in an infinite number of vertical lines. And if any one of those touches the graph in more than one point, it fails. So it can touch the graph in 1 point or 0 points. But it cannot touch the graph in any one line more than 1. So here, this one vertical line touches one time, and you can see because this goes forever and gets wider forever in both directions, any vertical line will touch this graph in 1 point. So conduct the vertical line test. If it passes, just check it off. Then I ask you, what is the domain? And the domain is all the possible x values that are involved with this graph. So if we go from any x value up or down, if we hit the graph, then that is in the domain. So you can see that any x value will be in the domain, even minus 1,000. Eventually this will reach across that area, and the graph will touch minus 1,000 for x. So the way we write that domain, we say domain equals, open brace, x is an element of the reals. Alright, the range is going to look at values that are for y. So we're going to say the range equals, open brace, y is an element of the reals. That tells the reader that we're not looking at imaginaries, we're in the real system. And what values will, for y, will be involved in this graph? Well, this value for y, say we're down here at -8 or something, if you go left or right, will you ever touch this graph? No, so -8 is not in the range. So what value will be the first one in the y direction in the range? Y equals 0 is 1, 2, 3, and so forth. So we're going to say y is an element of the reals such that y is greater than or equal to 0. So from 0 on up is our values for y that will connect to our graph. So that's the range, and we say it in this fancy pants way. X-intercept. Where does this function cross the x-axis? At 0, 0. What is the y-intercept? Where does it cross the y-axis? Also 0, 0. And no other y and x-intercepts. Where is it increasing? For increasing, we have to look at this from left to right, like we're reading a book. We read across the page from left to right. So we're going to put our little car on the graph to the left, and we see that as it moves to the right, it's going down. So that's the decreasing part. We're indicated with what this is a coordinate, but this is called an interval notation. It's not a coordinate. It looks like one, but it's not. So it tells me that this will be decreasing from x. These are all x values, -infinity to 0. And we have intervals with parentheses, means that the value is not including the endpoints, non-inclusive. All right, so then decrease, I'm sorry, that was supposed to be decreasing. I have this fancy pencil here with, I can get the eraser out now. Decreasing, I don't know why I wrote increasing. I'm doing decreasing first, then increasing. You can see over here the little car starts increasing once we hit the x value of 0, and it goes out forever. So 0 to infinity. We put the lower value to the left, the higher to the right. We separate them with a comma, and we say whether 0 and infinity are included or not. It's clear that infinity is never reached, so infinity and -infinity will never be included. And the 0 value could go with either section, so we do have a choice. We could say that it does include the 0 value, and that way we would put a bracket. All right. Constant. Is there any values for this graph? Are there any values where it is not increasing or decreasing? So it looked like this for that interval. There is not. So no intervals which are constant. Let's look at the symmetry. The symmetry, there's 3 values of symmetry. Symmetry is either x symmetry, y symmetry, or symmetric to the origin. So it's symmetric to the x-axis if whatever is above happens below. So something that would be symmetric to the x-axis. It's like the x-axis would cut it into identical halves. If I could fold this paper along the x-axis, this would imprint this, and that would be x-symmetry. We do not have x-symmetry here. Y-symmetry is when you fold across the y and one side imprints the other. We do have y-symmetry. All right, and symmetric to the origin is sort of a strange duck, but I will explain it to you. And say this is like an ellipse. So it's longer this way than it is this way. And if you can put a straight line through the center of the figure, and we're going to say put in an infinite number like our brains can do, and if each line, the intersection points on the figure, so this line intersects the figure here and here, if these 2 points are equidistant from the center, in this case the origin, and that's true for any line I draw that's straight, this one is the same distance for the origin as this one. So if that happens on every single line, then we say it's symmetric to the origin. So the circle would be symmetric to the origin. Let's look at our old friend, the hyperb. It's the hyperbola. So if I put a line through the center here, and I hit this point here and here, if I'd drawn a true hyperbola, these would be equidistant, and it would happen for any line. So it also is symmetric to the origin. All right, so on our example, we have symmetric to the y-axis. All right, after symmetry, we have, is it even function, an odd function, or neither? All right, so let's work on that. And this page, you'll have extra notes on the absolute value, so you can refer back. An even function, we have this statement to be true. F of x equals f of negative x. So, for example, if I have a graph that looks like this over here, and like this over here. Alright, so if I want to test this theory. If I go out x in this direction, say that's x right there, and I find f of x, so that means I go up and hit the graph and I read the value of f of x on the y-axis. So this is x and this is f of x, and I'm going to read its value right here. Maybe it's 3. We'll say it's 3. 1, 2, 3. So that value there on the y-axis is 3. Now, if I go out the same amount on the other side, negative x, same value the other direction, so this is negative x, and I look at f of negative x, I go up or down until I hit the graph to go up, and you see its value is also 3. So if f of x equals f of negative x for all spots, it's an even function. So you can see it's similar to y. It is the same as y symmetry. If I fold along this line, this will imprint that, and we have an even function. Odd function, f of x does not equal f of negative x, but negative f of x equals f of negative x. For example, suppose I have a function that goes like this on this side and like this on this side. So if I go out x, say that any place, say that's x, and I go out negative x, you see that f of x here is right there, and f of x on this side is right here. So they're the same value but the opposite sign. That's an odd function. So in this case, we see that if we go out x and negative x, we get the same value for f of x. So we have an even function. If it doesn't act like that either way, we call it a neither. And the last thing is relative maximum value or minimum value. And that's the highest y or the lowest y that the graph has in a specific area. So is there an area of this graph where it has one point that's lower than the surrounding points or higher than its surrounding points? Well, you see, this goes forever, so we're not going to see any maximum value, because if I pick one, there's always one that's higher in the y value. But this one here is the lower, or the lowest, y value, and it takes place, so there's no max, relative max, but the relative min is 0, 0. Alright, so you can see, like, if a graph does something like this, this could be a relative min. It's lower than everything that's close by it, all its neighbors, has a relative max and another relative min. Even if this one is higher than this one, it's still a relative minimum. Alright, I think that will get you all the values that you need for an example. So I'd like you to start the next one, and I will assign y equals square root of x. So we call that square root function. And I want you to graph it. And you'll recall that starts abruptly here and it grows slowly. And I'd like you to begin all of these things so rewrite these, write your neatest, because I'm going to actually grade it in your comp book. I want you to conduct the vertical line test, to find domain and range, xy intercepts, decreasing, increasing intervals, where it is constant, symmetry, is it even or odd or neither, and find relative min and max values. Try that for the square root function, write neatly, and if you have some that you're unsure about, make sure you're writing in pencil, give it your best shot, and we'll go ahead and check this one together. Then you'll be on your own to finish the other 6 parent functions, and that's part of your classwork when you get to it. Alright, that's it. I'm talking to you on Thursday evening and thinking of the fact that we're not going to Hershey Park tomorrow, and I'm glad because of the weather conditions. And I do hear that we are leaving at 11 on that day after finals. So we'll make the best of that. We can stay later because there basically is no class the next day on June, what is it, 7th? Was that the date that was reassigned? Well, you know, you got an email from Mrs. Miller. So even though we'll get a little later start, we get to stay later as well. So I hope that works out for all, and we can look forward to it and hope the weather and pray that the weather's better that day. All right, so this is our parent function project in our comp books, written neatly for evaluation. Okay, class, that's it. Carry on.